For this problem, we're going to perform a Hess law. We have N2O gas plus 1/2 O2 gas goes to 2 NO gas. We want to find the delta H of this reaction. Using the equations below, solve the delta H for the target reaction. Go ahead and pause and give that a try. All right, if you're back, well, to start, we need to pick a chemical in our reaction that shows up in only one of the other reactions. Let's look and say, hey, what about NO? Well, NO shows up in A, but it also shows up Let's look at dioxygen. Dioxygen shows up in both. This is not useful. We don't know which one and how much. We're going to use both of these equations, and so however much we use of each one will affect the other. Oxygen is a bad place to start. Let's try N2O. Well, hey, there's N2O in only one of our reactions. So all of our N2O must come from reaction B. I want one of it on the left. Reaction B gives me 2 of it on the left. So I need to modify B. I need half of B. I need to tone it down. This will give me just a single N2O gas. This will give me 3/2 O2 gas. So 1.5. That's going to give me 2 NO2 gas. And a delta H of negative 14 kilojoules, just half the size. Well, that gives me one of the things I need, but I have all these other components. I don't want NO2 in my reaction at all. If I go look at A, well, there's NO2. I can use A to cancel the NO2 in B. Problem is the NO2 in B was on the right. To cancel it, I need A's NO2 to be on the left. And the only way to do that is to flip it around. So I need a flip of A. It comes with 2 NO2s, but, well, that's what I have from my modified B. So that's okay, I just need to flip A. 2 NO2 gas will now be on the left for my modified A. That'll give me 2 NO gas over on the right, and O2 gas over on the right. And so we flipped A, which means the delta H naught is now positive 113.2 kilojoules. If I add these equations together, well, everything on the left will be on the left, everything on the right will be on the right. So let's look. I have some NO2s on the left, and I have some NO2s on the right. 2 and 2, they will cancel out. I have some O2s on the right, and I have some O2s on the left. Well, how many? 2 out of 2 versus 3 out of 2. The 2 out of 2 will cancel on the right, but only 2 of them will cancel, leaving me with 1/2. So 3/2 minus 2/2 will leave you with 1/2. Go and combine these. My N2O gas, my 1/2 remaining dioxygen on the left, and my 2 NO gases on the right. By modifying these 2 reactions this way, one being flipped, one just being cut in half, and then combining them, I create the equation I want. So my delta H for this reaction, well, you do the same changes to the original energies, which we calculated here, and then you just sum them the same way we sum the reactions. Negative 14 plus 113.2 is going to be 99 0.2 kilojoules. The delta H for this reaction is 99.2 kilojoules positive. So we can rearrange the equations we are provided to calculate out the target equation in order to find the enthalpy change of the target equation.